Welcome to my 70th tutoring session in A-level chemistry. In this video, I'll explain the working principle involved in IR spectrometer. Now there are three types of IR spectrometer instrument: dispersive type, Fourier transform type, and ATR type. Now the dispersive type instrument uses the monochromator, while the Fourier transform type IR spectrometer, it utilizes the interferometer. Now, before I explain the working principle involved in the IR spectrometer, I would like to give a brief account about the infrared radiation. Now, the electromagnetic spectrum, it extends from the high energy gamma rays to the low energy microwave and radio waves. And the energy of the radiation is given by the equation E is equal to hf, where E is the energy of the electromagnetic radiation, h is the Planck's constant, and f is the frequency of the radiation. As you move from high energy gamma rays towards the low energy microwave and radio waves, you see that the wavelength increases. Now, what is wavelength? Now, wavelength is the distance between two successive maxima or minima. So as you move from high energy gamma rays towards the low energy microwave and radio waves, the wavelength increases and the energy decreases. And as you move from low energy microwave and radio waves towards the high energy gamma rays, the frequency increases. Now, frequency is the number of wavelength units that pass through the fixed point in unit time. So as you move from the low energy microwave and radio waves towards the high energy gamma rays, not only the frequency increases, but also the energy of radiation also increases. Now, one complete wave is constituted by one maxima and one minima. So a complete wavelength unit is one maxima plus one minima. So hence the frequency will be the number of wavelength units that passes through the fixed point. Now here in this case, you can see around 2 waves have passed through this fixed point, and hence the frequency will be 2 hertz. So 1 hertz will be 1 cycle per second, 2 hertz will be 2 cycle per second. Now the infrared region, it comprises of near region, mid region, and the far region. Now of these three regions, the middle infrared region, which provides wavelength ranging from 400 to 4000 centimeter inverse, is of analytical interest as it is utilized for structural elucidation and functional group determination. Now the infrared region in the range of 400 to 4000 centimeter inverse, it induces bond vibrations. That is, it has the sufficient energy to bring about both bond stretching as well as bond bending. So that is the significance of higher region. So it can induce bond vibrations like bond stretching and bond bending. Now wave number is the number of waves per centimeter. It is reciprocal of the wavelength and hence the unit centimeter inverse. So wave number is the number of waves per centimeter of the given wave. Now generally IR absorption peaks in the spectra, they are mentioned in terms of wave number. That is, they usually consider the reciprocal of the wavelength and thereby end up with the unit of centimeter inverse. So why is that? Why do they consider the wavelength unit in wave numbers and not in meters or centimeters. Now reason is that now the wavelength unit in terms of centimeter will be in decimal values, and it will be very difficult to handle these small values with decimals. So when you take reciprocal of this, say for example, the length of the wave is 0.002 centimeters, and when you take the reciprocal of this particular value, you'll end up with a huge number, that is 500. So when you take reciprocal of this number, you end up with 500 centimeter inverse. So which is more convenient to handle? So definitely it will be the huge number that is more convenient to handle rather than the values in decimals. So when interpreting IR spectra, organic chemists often prefer using wave numbers instead of wavelengths. Now this preference for wave number units, it can enhance the convenience and clarity in discussions related to IR spectral analysis. So when the organic chemist is trying to interpret a particular spectra, these used values in centimeter inverse helps him to carry out the interpretation easily. So it's always better to use the wave number units. And that is why IR absorption peaks are mentioned in terms of wave numbers and not in wavelengths. Now IR radiations, they bring about bond stretching vibration. When the IR radiation strikes or impinges the bond interconnecting the two atoms of masses m1 and m2, there are two possible outcomes. The first outcome is that the bond length may decrease, and the second outcome is that the bond length may increase. So when the IR radiation strikes the bond interconnecting the two atoms with masses m1 and m2, two possible outcomes: either the bond length may decrease or the bond length may increase. IR spectrometer is a benchtop computer controlled instrument that is used for functional group determination of organic compounds. And the instrument, it measures the intensity of IR radiation absorbed by the sample. And the instrument is attached to a computer system, and thereby it enables the operator to not only visualize the displayed spectra on the screen, but also to carry out easy interpretation of the resultant spectra that is displayed on the screen. Now IR spectrometer instrument, it comprises of an IR light source, a sample compartment where the sample is handled, and the detector. Now the IR light source, it provides the IR radiation, and this IR radiation provided by the IR light source, it has the right energy to induce bond vibrations like bond stretching and bond bending. Now when the IR radiation given out by the source, when it strikes the sample, certain amount of the incoming IR radiation is being absorbed. Let's say for example 50% of the incoming IR radiation is absorbed by the sample, and let us represent it by IA. So IA is the intensity of IR radiation absorbed by the sample. And what happens to this absorbed radiation, and how does the sample utilize it? Now the IR radiation, it is absorbed by the sample, and it is actively involved in bringing about bond vibrations like bond stretching and bond bending. So the energy of the IR radiation is utilized in bringing about bond vibrations. So molecules absorb specific IR frequencies that match their bond vibrations. Some wavelengths are being absorbed, causing bond vibrations like stretching and bending, while the unabsorbed radiation, it reaches the detector. Now, for example, IR frequencies of around 3000 to 3200 centimeter inverse, it brings about stretching of the bond interconnecting oxygen atom and the hydrogen atom. While IR frequency of about 1670 centimeter inverse, it brings about stretching of the double bond interconnecting the carbon atom and the oxygen atom of the carbonyl group. So the functional groups, they absorb specific IR frequencies and thereby bring about the stretching and bending vibrations. So this IR frequency is very specific towards a particular functional group. Now what happens to the unabsorbed radiation? So 50% of the radiation is being absorbed, represented by IA. And what happens to the left out unabsorbed radiation? So the unabsorbed radiation that is transmitted through the sample, it falls on the detector. The functional role of the detector is to measure the intensity of this unabsorbed radiation falling on the detector. So the detector measures the intensity of IR radiation. It compares the amount of IR before and after the sample. And as a result, a spectrum is created, which is displayed on the screen. And the peaks in the IR spectra, they correspond to absorption by the functional groups at specific frequencies. So peaks in the IR spectra, they help identifying the functional groups like OH group, CO group and NH group. So the computer, it displays the spectrum. So the output which is displayed on the screen is a graph of transmittance or absorbance on the y-axis versus the wave number in centimeter inverse on the x-axis. And I've already explained the significance of this wave number. Why the organic chemist prefers the wave number rather than wavelength. Now, why do the peaks appear in the IR spectra? Now, the peaks appear due to absorption of the infrared radiation by the functional groups at specific frequencies. So whenever there is absorption of radiation, the peaks appear. Now initially, this is the IR spectra of the classical painkiller paracetamol. Now initially in the IR spectra of paracetamol, you see that there are no peaks. When there are no peaks, then definitely you can take it for granted that there is 0% absorbance, or you can say there is 100% transmittance of the IR radiation. And later you see peaks appearing where there is 50% absorption of the sample, or you can say 50% transmittance. And again, there are no peaks appearing in the spectra. That is again because the IR radiation is not being absorbed by the sample. There is 100% transmittance of the incoming IR radiation. So whenever peaks appear in the spectra, it means that the functional groups, they absorb the IR radiation at specific frequencies. For example, here in case of the paracetamol, you see a sharp peak at around 1670 centimeter inverse, indicating a presence of carbonyl group, which you can see in the structure. And a broad peak around 3000 to 3200 centimeter inverse indicates the presence of phenolic OH group. So because of the CO stretching, you see a peak at 1670 centimeter inverse, and due to stretching of this covalent bond between the oxygen atom and the hydrogen atom, it brings about a broad peak around 3000 to 3200 centimeter inverse. Now in the next video, I'll be explaining the different regions in the IR spectra, like fingerprint region and function group region. And I'll also be explaining the important function group frequencies that one should be aware of while interpreting the IR spectra of a given organic compound. Thank you so much for watching my video. I hope you enjoyed it, and I'll meet you in my next interesting tutoring session.